Good evening, good morning, or good afternoon, depending where in the world you are. Welcome to the first World Harbor Project webinar. I suspect I know most of you, but for those who I don't know, my name is Peter Steinberg. I'm the director of the Sydney Institute of Marine Science and also the director of the World Harbor Project.
There's a goal in terms of restoration at the moment to make it productive again. We have a billion oyster project, which combines both education and citizen science goals to restore 1 billion oysters, which is what was believed to be the original population when Henry Hudson first entered the estuary.
So the watershed spans these different physiographic provinces with the Appalachian Plateau, then this Ridge and Valley series, and then the Piedmont, which is rolling hills, which was deep sediments which were formed from the erosion historically of the Appalachian Mountains, and then this broad, flat coastal plain. And then the fall line, note where that is. That's where the sailors would go until you encounter the first waterfall, and that becomes very significant in the historical development of the bay.
If you look inside these units, this is what they effectively look like. There's rock armoring underneath in the core, and then we poured concrete in on top of this. As it was setting, we placed these buckets in, made sure that they made depressions in the concrete, removed them after the concrete had set, and effectively they retained water and functioned like rock pools.
The units which are below mid-low water were replaced by units made by our mixes and our design, and the same size, the same quantity in terms of structural performance than the standard Portland cement you see on the top. And we're still monitoring this project now. It's 3.5 years in the water.
As I started building artificial reefs, and I originally started building them out of just junk material, I started to gain an appreciation for how marine life used constructed materials in the marine environment, an appreciation for how we really needed to build better.
We're actually looking for like the worst quality 3D print. So we sort of played around with, kind of hacked our 3D printer to try to get it to print, really bad quality so that we could produce this sort of weird texture that Dave was talking about to do with protected space to get maximizing colonization.
The research group here in Dublin have used that system in a number of experiments to look at the characteristics of the receiving environment. For example, Selonian crow and Kinselin crow looked at the effects of copper and freshwater on establishing and mature fouling assemblages.
Well, we are here in the Santander Bay, that at the same time you can see the 3 red lines that are the limit of the Santander Harbour. We will talk about a system that is a very human system. That means that the activities that have been developing in the last centuries in this area has been a mix of activities I will see later.
The rivers get rated from estuaries from A to F, A being excellent, obviously, and F being a fail. So they've got lots of estuaries to do, and they're doing it monthly. So the issue is that there's no way they can collect macrobenthix data to provide ecological endpoints. So to date, really, it's based on mainly on physical chemical measurements, turbidity, and also habitat.
Harbors are complex systems. In harbors, we have human activities that introduce substances, materials to the environment. These kind of substances affect the ecosystems.
Some things we know about urbanisation or the transformation of these natural substrata to hard substrata is that they replace rocky shores with seawalls that provide smooth and homogeneous structures. And they often don't replicate, or mostly they don't replicate the structures of rocky shores.
So we have a classic drowned river valley system here, although this is very much of a salt wedge estuary. We have a very large river at the head of the estuary, about 100 cubic meters per second. And it's a very highly stratified system. As you can see, freshwater overlying saltwater.
Can we use the algae, the macrophytes, to tell us a bit more about the changes in condition in the system? And she looked at seagrasses and algae, and in the end found that from the upper estuary through the middle estuary to the lower estuary, the levels, in this case copper, zinc and lead.
Over the last 2 decades, there's been great work done on contamination in Jakarta Bay. That science is immediately fed into the banning of all fishing in Jakarta Bay and the banning of collection of mussels. but we know that it's still happening. There's still a delicacy in Java. The reality versus the sort of just identify the contaminants and then ban it is one that we need to be a bit more aware of, I think.
Import all of your different data, map out different areas on the plan, and it gives you analytics on how that delivers on environmental and economic outcomes, as well as your social outcomes if you have that data. And you can talk to each other through the tool and compare maps and basically work together to develop the ultimate solution for your area.
One of the strengths, I think, of the World Harbour Project is that we get different societal and cultural perspectives on the kinds of issues that we're interested in.
The industrial is not a big problem, it's very stable, but with the increase of the population, we have a really big problem for the domestic city.
Our schematic design for this eco-solar engineering project, we will plant some backshore vegetation to connect the land ecosystem to the marine ecosystem. Then we have mango plantation, the bio block, and also we'll have the oyster basket. The oyster will function to clean up the water and also could be used for consumption.
Despite this structure constitute the main hard substrate of the coast, they host mainly ephemeral and non-native species. Moreover, in general, we observed that these artificial structures host populations with lower genetic variability compared to the natural habitats.
We're generating some useful data on the oyster monitoring process. We hopefully will start to generate some really robust data on biological monitoring, biological populations of sessile and mobile invertebrates. But we're really getting a really nice uptake from the community and a really nice spread of groups.
We've done very well, and thank you very much to both our speakers, Paolo and Alyssa, for sharing your wonderful presentations with us today.